Earth's largest natural crystal took 500,000 years to grow, exists in a cave where humans can only survive 10 minutes unprotected, and contains reanimated ancient microbes that match nothing in our genetic databases.
Yeah, it represents this incredible convergence of extremes. You've got an environment that is simultaneously one of the most hostile natural spaces on the planet, and yet it's this incredibly fragile window into deep geological time.
And the absolute limits of biology.
Exactly.
Well, welcome to this deep dive into the Cave of Crystals. I'm your host, and I'm joined by a resident geology and astrobiology expert to unpack a subterranean marvel. It's located in Chihuahua, Mexico, specifically within the Sierra de Naica.
Hi, everyone. Yeah, today we are taking a massive stack of sources. We're talking detailed geological surveys, peer-reviewed scientific journals, expedition reports, and we're synthesizing all of that to truly understand this place.
Right, so our mission today is to essentially unpack the lethal, perfectly balanced conditions that created this geological masterpiece and, figure out what the truly alien-like life found inside it means for the future of astrobiology.
Because we are dissecting a system where thermodynamics, hydrogeology, and absolute isolation operated in this flawless, uninterrupted equilibrium for 500,000 years.
It's just wild.
It really is. It's a system that completely defies common intuition about how our planet works.
And I want to speak directly to you, the listener, right now. As we go on this journey today, I want you to really internalize that you are about to explore a place you can never physically visit.
Yeah, it's completely off limits now.
Right, it is entirely off limits. I mean, it is a geological masterpiece, yes, but it is also an absolute death trap.
Oh, without a doubt.
So to understand the sheer impossible physics and biology of this chamber, we need to trace the steps of the people who accidentally tore the roof off this hidden world.
And the human element of this discovery is fascinating, mostly because it was entirely inadvertent. We are talking about April of the year 2000, in an industrial setting that could not be further removed from careful scientific exploration.
Right, picture the setting, right. The Naica Mine is this heavily industrialized, massive operation run by the Industrias Peñoles mining company. We're in the Chihuahuan Desert, which, is already a pretty harsh surface environment. But underground, it is this vast, crisscrossing labyrinth of tunnels designed to extract silver, zinc, and lead.
And the scale of the mining operation there is really crucial context. This isn't just a small tunnel. It's basically a subterranean city. And at the 300-meter level, so that's nearly 1,000 feet straight down into the Earth's crust,
right.
The environment is punishing. It is loud, it's dusty, and incredibly hot, just due to the geothermal gradient of the rock itself.
Right. The deeper you go, the hotter it gets.
Exactly. So two miners, these brothers, Juan and Pedro Sanchez, they're tasked with drilling a new access tunnel through a specific geological feature known as the Naica Fault.
Now, drilling into a fault line sounds like a textbook hazard in the mining industry. I mean, faults are essentially giant cracks in the Earth's structural integrity, right?
Yeah, they're fractured zones.
Yeah.
And in deep Earth mining, the primary terror associated with a fault line isn't an earthquake, it's actually water.
Wait, water?
Yeah, faults act like these massive underground highways for aquifers. So if you drill into a highly pressurized, water-bearing fault, you risk this explosive influx of water that can it can drown a mining level in minutes.
Oh, wow.
So the Sanchez brothers are advancing their drill very carefully. They're constantly monitoring for moisture, basically expecting at any moment to hit a solid wall of water.
But the water never comes. Instead, the drill bit just punches straight through the rock into an empty void. And the air that blows back out of that hole isn't normal ambient mine air.
Not at all. It was this violent exhalation from the mountain. The air that hit them was overwhelmingly hot, fully saturated with moisture, and it carried this heavy, acrid smell of sulfur and ancient stone.
Just this blast of heat.
Yeah, it was the atmospheric signature of a sealed geothermal pressure cooker.
I always try to imagine the sheer sensory shock of that moment. They widen the hole, they shine their heavy industrial cap lamps into the darkness, and the light doesn't just hit a flat wall of limestone.
No, it scatters.
Right. It refracts and bounces off these massive translucent surfaces, throwing this pale, cold, fractured glow back at them from just every conceivable angle.
Yeah, they had broken into a horseshoe-shaped chamber, roughly 109 meters long, dominated by a massive central cavern.
And the visual is so staggering that the human brain initially just struggles to parse the geometry, or it looks rendered or like artificial.
Yeah, because the light is catching on these massive beams of selenite, which is the transparent crystalline variety of gypsum, and they're jutting out of the floor, the walls, and crisscrossing through midair at impossible angles.
My absolute favorite analogy for this is stumbling into Superman's fortress of solitude. But, instead of being carved out of pristine Arctic ice, it's buried 1,000 feet beneath the baking Mexican desert.
It's a great analogy.
Let's talk about the exact measurements of these beams, because the scale is where a lot of people just lose their grasp on reality.
And this is where we have to rely strictly on the rigorous surveying done by geological teams.
Yeah.
Gypsum itself is incredibly common, right? Like if you have drywall in your house, you are surrounded by gypsum.
Sure.
But the selenite crystals inside this specific chamber grew to proportions never seen anywhere else on Earth. The largest confirmed, scientifically documented beam in the cave is 11.4 meters long.
Okay, 11.4 meters. So that translates to what, 37.4 feet?
Exactly.
So you are standing next to a single, unbroken geometric structure the size of a 4-story building.
Yeah, with a thickness of about 1 meter and an estimated weight of 12 tons.
Okay, I want to pause on that 12-ton figure for a second. Because if you, the listener, go down the inevitable internet rabbit hole on the Naica Cave after this deep dive, you are going to encounter wildly different numbers.
Oh, definitely.
You will see reputable-sounding videos and articles claiming there are crystals weighing 55 tons or measuring 4 meters thick.
Right, and those numbers are a really fascinating case study in how scientific data gets distorted through, like, the telephone game of the internet.
Right.
The 55-ton, 4-meter thick claim is completely a myth. It seems to have originated from a miscalculation or maybe a misinterpretation of a cluster of crystals, rather than a single distinct beam.
So a bunch of them mashed together.
Right. The 11.4-meter, 12-ton measurement is the absolute maximum verified by the speleologists who actually mapped every inch of that cavern.
Which, let's be honest, we don't need to exaggerate.
No, not at all.
A 12-ton, flawless, natural crystal the size of a city bus is more than enough to break the brain. And it's especially mind-blowing when you compare it to what the miners thought they were going to find. Because the Cave of Crystals wasn't the first crystal chamber found in this mountain.
Right, and that historical precedent is a vital piece of the geological puzzle. 90 years prior to the Sanchez brothers' discovery, so back in 1910, miners working much closer to the surface at a depth of about 120 meters broke into a different void.
And they named it the Cave of Swords.
Yeah, they did.
It's an incredibly evocative name.
And it fit the visual perfectly. The Cave of Swords was also entirely encrusted with selenite crystals, but they were vastly different in scale. They were mostly 1 to 2 meters long.
Literally the size and shape of broadswords jutting out of the walls.
Which is spectacular in its own right.
Yeah.
But unfortunately, because it was discovered in 1910, long before modern geological preservation protocols, it suffered heavily.
I can imagine.
Yeah, miners, locals, and eventually commercial collectors systematically looted it. The most beautiful specimens were broken off and carried away.
That's such a shame.
It really is. But the tragedy of the Cave of Swords actually provides us with a crucial data point. The difference in depth, 120 meters for the Cave of Swords versus 300 meters for the Cave of Crystals, is the master key to understanding the thermodynamics of how these structures grew.
We will definitely dig into the mechanics of that depth difference in a moment. But first, I want to point out a massive logical contradiction here.
Okay, let's hear it.
If the Cave of Crystals is 300 meters underground and the entire Sierra de Naica region sits directly over a massive aquifer, how did Juan and Pedro Sanchez walk into an empty room?
Ah, right.
By all laws of hydrogeology, that 300-meter level should have been completely submerged under millions of gallons of water.
It absolutely should have been. The Cave of Crystals sits roughly 160 meters below the natural historical water table of the region.
So it should be completely flooded.
Right. The fact that the chamber was filled with air instead of water is entirely artificial. Industrias Peñoles had been engaged in one of the most aggressive dewatering operations on the planet.
Let's expand on what a dewatering operation actually means at this scale, because to mine silver and lead at that depth, you have to fight the mountain constantly.
You are fighting the entire regional hydrology. To keep those deep tunnels dry enough for humans and heavy machinery to operate, the mining company installed massive banks of industrial pumps, and they were pulling water out of the ground at a rate that is, frankly, difficult to conceptualize. Our sources indicate they were pumping the equivalent volume of an Olympic-sized swimming pool out of the mountain every 40 minutes.
Wait, an Olympic swimming pool every 40 minutes?
Every 40 minutes. Around the clock.
That is, just imagine the sheer violence of that engineering. The electricity required, the acoustic roar of the pumps echoing through the tunnels, these massive pipelines moving rivers of water to the surface day and night for decades.
It's an incredible feat of engineering.
And in doing so, they essentially emptied the bathtub.
They artificially depressed the water table across the entire region. The water level dropped meter by meter year after year until it eventually fell below the 300-meter mark.
Wow.
So without realizing it, the mining company drained the cave of crystals, exposing it to the air for the first time in hundreds of thousands of years.
So humanity only laid eyes on this geological masterpiece because of a brute force industrial operation.
Exactly.
But removing the water didn't just reveal the cave, it activated its defenses. It turned the space from a submerged wonder into an atmospheric nightmare that is actively, aggressively hostile to human physiology.
Yeah, hostile is almost an understatement here. The baseline metrics of the chamber's atmosphere push right up against the absolute biological limits of the human body.
Right.
When the water was drained, it left behind an ambient air temperature that sits consistently between 50 and 58 degrees Celsius. For those using Fahrenheit, that is up to 136 degrees.
136 degrees. If you ask someone to imagine 136 degrees, they might think of, I don't know, Death Valley on the hottest day of the century.
Sure.
But Death Valley is a dry heat. The lethal variable in the Cave of Crystals is the moisture. The relative humidity inside that chamber hovers between 90% and 99%. It is basically a completely saturated, boiling fog.
Right, and the combination of those two numbers, 58 degrees Celsius and 99% humidity, creates a thermodynamic trap. It neutralizes the human body's primary defense mechanism against heat.
To explain why that combination is so lethal, I want to use the analogy of a swamp cooler.
Hmm.
A lot of homes in arid climates use swamp coolers instead of traditional air conditioning,
Right, they're very common in dry heat.
A swamp cooler pulls dry outside air through water-soaked pads. The dry air absorbs the water, and the physical process of evaporation draws heat energy out of the air, blowing cool air into the house.
It relies entirely on the phase change of water from liquid to gas.
Exactly. And the human body is essentially a biological swamp cooler. When your internal temperature starts to rise, your brain triggers your sweat glands. You push liquid water onto the surface of your skin. If you are in a dry environment like Death Valley, the air acts like a sponge. It absorbs your sweat, the sweat evaporates, and that phase change pulls the heat away from your skin, cooling your blood.
But a sponge can only hold so much water.
Right. And at 99% humidity, the air in the Cave of Crystals is a completely saturated sponge. It cannot accept a single additional molecule of water vapor.
So your sweat has nowhere to go.
Exactly. So your body initiates the swamp cooler protocol. You sweat profusely, but the sweat just sits on your skin, hot and pooling. The evaporation process is physically impossible. The swamp cooler is broken.
And the physiological cascade that follows is terrifying. Because your body cannot dump heat into the environment, and because the ambient environment is actively pumping heat into you, your core temperature begins to spike.
Right.
To compensate, your cardiovascular system just goes into overdrive. Your blood vessels dilate massively in a desperate attempt to push blood to the surface of your skin to cool it.
But the skin is boiling, so the blood just absorbs more heat and carries it back to your internal organs.
Yeah, your heart rate skyrockets to try and move the blood faster. The thermal strain accelerates. The humidex, which is the perceived temperature index combining heat and humidity, inside that cave is calculated at between 90 and 100 degrees Celsius.
Oh my God.
That is the boiling point of water.
I always ask people to imagine opening an oven door when you're baking something at a high temperature. You get that initial blast of suffocating heat that makes you physically recoil.
Yeah, everyone knows that feeling.
Now imagine that heat blast, but you can't step back. You are immersed in it, and it's pressing against every square inch of your skin.
Under those conditions, an unprotected human has a maximum survival window of perhaps 10 to 15 minutes.
10 to 15 minutes, that's it.
That's it. Beyond that, the hyperthermia becomes critical. The brain begins to overheat, leading to severe cognitive disorientation, lethargy, hallucinations. Ultimately, the cardiovascular system collapses under the strain of trying to cool a body that just cannot be cooled.
As terrifying as the skin-level thermal physics are, it's not even the most horrifying part of the environment. I want to talk about the lung phenomenon.
Yeah, this is where it gets really grim.
Because when I first read about this, I thought, well, if the air is bad, Couldn't an explorer just bring in a standard amoeba tank or a firefighter's oxygen rig?
That is a very common assumption.
Yeah.
But adding oxygen doesn't solve the core mechanical problem of taking a breath in that room. It's a thermal issue, not an oxygen deficit issue.
Break down the mechanics of a single breath in there for us.
So consider the temperature differentials. The normal internal core temperature of a human being is roughly 37 degrees Celsius. The air inside the cave is 58 degrees Celsius.
Okay.
That means the internal tissue of your lungs is a staggering 21 degrees cooler than the air you are breathing in.
Right.
Now remember that the 58-degree air is 100% saturated with water vapor. When you inhale, you pull that superheated, heavy, saturated vapor down your trachea and into your bronchioles.
Oh, no.
When that vapor hits the 37-degree tissue of your lungs act like a cold glass of water sitting on a table on a humid summer day.
The dew point.
The dew point is reached inside your respiratory tract. The vapor cannot remain a gas at that lower temperature, so it condenses back into liquid water directly onto the alveolar sacs of your lungs.
You are literally, breath by breath, slowly drowning yourself in your own condensation.
Exactly. The water fouls the gas exchange surfaces. It creates a physical barrier that prevents oxygen from crossing into your bloodstream. Every breath you take yields less oxygen than the last, while simultaneously delivering another lethal dose of heat directly to your core.
It is an environment engineered by geology to execute biological organisms.
It really feels like it.
And this lethal reality birthed a very grim piece of local lore at the Naica Mine, didn't it? A cautionary tale about a man who didn't respect the physics.
Yeah, it is a dark anecdote, but it's widely circulated among the miners. Soon after the discovery, Industrias Peñoles recognized the extreme danger and installed a heavy, double-reinforced steel door over the entrance to prevent anyone from wandering in.
Makes sense.
But the lore suggests that a rogue miner, or maybe a thief, motivated by the potential black market value of the crystals, managed to bypass the security and slip past the door.
Which, the motivation makes sense. If those crystals were in a museum, they would be priceless.
According to the story, this individual knew the air inside was unbreathable, but he fundamentally misunderstood why it was unbreathable. He reportedly brought several large plastic bags filled with fresh, cool air from the main mine shaft, intending to breathe from them while he hacked off a piece of selenite.
So he thought it was a toxic gas problem. He didn't understand the thermodynamics at all.
Right, and the fresh air in his bags would have equalized to the 58-degree ambient temperature almost immediately anyway.
Oh, true.
And regardless of the air he was breathing, his swamp cooler was broken. The overwhelming thermal mass of the environment triggered massive hyperthermia within minutes.
Wow.
He succumbed to cognitive disorientation, became too weak to navigate back to the heavy steel door, and perished among the giant beams.
That's horrifying.
While the specific details of the story might be embellished through retelling, the scientific mechanics of his demise are absolutely sound. The cave will kill you, silently and swiftly.
Which brings up the obvious logistical nightmare. We have incredibly precise measurements of these crystals. We have geological samples. We have biological data. How on earth did scientific teams survive long enough to do rigorous, highly delicate research inside a boiling pressure cooker?
Well, they had to rely on custom-engineered technology that, frankly, borders on the kind of life support systems you see in aerospace. You couldn't just walk in with a hard hat, a flashlight, and a bottle of water.
They needed armor against the heat.
Specifically, armor designed by the Italian speleologist Pello Forti and utilized extensively by researchers like astrobiologist Penelope Boston during their major expeditions. They deployed specialized gear known as Ptolemaea cooling suits.
I've seen pictures of these and they look incredibly bulky. They remind me of the liquid cooling and ventilation garments that Apollo astronauts wore under their pressure suits.
Yeah, the engineering principle is nearly identical. The Ptolemaea suit is a full-body undergarment threaded with an intricate network of narrow, flexible tubing. Over this, the scientists wore a heavy, insulating protective layer, often a bright orange or silver coverall, to keep the ambient heat out.
Right.
But the critical component was the backpack.
So they were carrying their own personal refrigeration units.
Essentially, yes. The backpacks were loaded with dense, pre-frozen ice packs and a battery-powered pump. The pump circulated chilled water continuously through the tubing across their chests, backs, arms, and legs.
That's brilliant.
It acted as an artificial circulatory system, pulling the metabolic heat out of their bodies and dumping it into the melting ice on their backs.
That solves the core temperature issue, at least temporarily. But what about the lung condensation problem? How do you stop yourself from drowning on the air?
So they paired the Ptolemaeus suits with devices called sinusite respirators. These were specialized breathing masks sealed over the nose and mouth, connected by hoses to a chilling chamber in the backpack.
Okay, I see.
The respirator pulled the 58-degree ambient air through a cartridge device, which simultaneously dropped the temperature of the air and forced the moisture to condense inside the cartridge rather than inside their lungs.
Wow. So they were breathing cold, dry, filtered air, but even fully suited up like subterranean astronauts carrying 40 pounds of ice and batteries. They weren't invincible.
Not by a long shot.
Yeah.
The thermal assault of the cave is so relentless that it overwhelms the engineering very quickly. The ice in the backpacks would melt at a terrifying rate.
I bet.
Even with the suits operating flawlessly, the researchers could only endure a maximum of 30 to 45 minutes of exposure before the thermal strain became dangerous.
Think about the psychological pressure of that. You are a scientist, you've traveled thousands of miles, you've secured funding, you're standing in front of the greatest geological discovery of the century, and you have a stopwatch ticking down from 40 minutes.
It's incredibly stressful.
You have to execute precise scientific protocols, taking samples, measuring angles, operating delicate equipment, while your body is screaming at you and the suit is failing.
And when that stopwatch hits zero, there's no pushing through it.
Yeah.
They had to drop their tools and execute an immediate mandatory retreat through the airlock door to a designated cool room that the mining company had excavated just outside the chamber.
And we have to clarify what a cool room means in the context of a deep earth Mexican mine.
Yeah, the cool room was heavily ventilated by the mine's infrastructure, bringing the ambient temperature down to roughly 38 degrees Celsius.
Which is 100 degrees Fahrenheit.
Right. To a researcher who had just spent 40 minutes inside a 136-degree boiling fog, a 100-degree room felt like walking into a meat freezer. It was their safe haven to strip off the heavy suits, rehydrate frantically, and allow their core temperatures to stabilize.
The logistics of just existing in that space are staggering, but here is the massive pivot point of this entire deep dive.
Okay.
The very heat and moisture that make this cave a biomechanical death trap for humanity. That isn't a tragic coincidence. That lethal atmosphere is the precise, flawlessly calibrated engine that built these giant crystals. The danger and the beauty are the exact same in this room.
Exactly. The Cave of Crystals is, at its core, a 500,000-year geological reactor. And to understand the mechanics of that reactor, we have to scale our perspective way back. We have to look at the deep time history of the Chihuahuan Desert, going back roughly 26 million years.
So 26 million years ago, long before humans, before most modern mammals, what was happening deep beneath the surface of what is now Mexico?
The entire region was subjected to intense tectonic stress. Deep beneath the limestone bedrock of the Sierra de Naica, volcanic activity caused a massive intrusion of magma to push upward into the Earth's crust.
Right.
It never breached the surface to form a volcano. Instead, it stalled out, forming a colossal magma dome about 3 to 5 kilometers below the surface.
I picture it like a massive subterranean hot plate turned on high.
A permanent geothermal hot plate. And the limestone rock above this magma dome was heavily fractured and saturated with deep groundwater. As the magma dome radiated heat, it turned that groundwater into a boiling, pressurized hydrothermal system.
Like the plumbing system beneath a geyser, but trapped underground?
Precisely. Now, this boiling water is highly corrosive, and as it circulates through the deep bedrock, it dissolves massive amounts of minerals. Specifically, it strips heavy metals like silver, zinc, and lead, which is what the miners are there for today. But it also dissolves immense quantities of sulfide ions and calcium.
So you have this high-pressure, superheated subterranean soup, absolutely choked with dissolved calcium and sulfate.
Yes. In the early stages of this geological timeline, the water in the Naica Fault was extremely hot, well over 60 degrees Celsius. Under those high-temperature conditions, the calcium and sulfate ions in the water want to bond together and precipitate out of the liquid as a solid mineral.
Okay.
But they do not form gypsum. At those extreme temperatures, they form a different mineral called anhydrite.
Let's break down the chemistry here, because the distinction between anhydrite and gypsum is the secret to the entire cave. They are both calcium sulfate. What is the fundamental difference in their molecular structure?
The crucial variable is water. The word anhydrite literally means without water. It is a tightly packed crystalline lattice of calcium sulfate that contains no water molecules within its structure.
Got it.
Gypsum, on the other hand, is calcium sulfate dihydrate. Its crystalline lattice actually incorporates water molecules directly into its geometry.
So when the water was superheated by the magma dome, the dissolved minerals precipitated out as this dry, compact anhydrate, coating the walls, the floor, and the ceiling of the cavern.
Right. Vast deposits of anhydrate filled the fractures and the voids. And here's the defining thermodynamic threshold of the Naica system. Anhydrate is only stable at high temperatures.
Okay.
Specifically, it remains a stable solid as long as the surrounding water remains above 58 degrees Celsius.
58 degrees. That is the magic number for this entire ecosystem.
As long as the water is 58 degrees or hotter, anhydrate is happy and gypsum cannot form. But magma domes do not stay hot forever. Over millions of years, the magma intrusion deep below the Sierra de Naica slowly, incrementally began to lose its thermal energy to the surrounding crust.
The hot plate is slowly turning itself down.
Very slowly. And as the magma cooled, the temperature of the hydrothermal soup in the Cave of Crystals began to drop. Millennia after millennia, the temperature crept downward, approaching that critical 58-degree threshold.
And eventually it crosses the line. The temperature of the water dips to 57 degrees. What happens to the anhydrate?
The thermodynamics flip. Below 58 degrees, anhydrate becomes chemically unstable. The massive deposits of anhydrate coating the walls begin to slowly dissolve back into the water, releasing a steady, endless stream of calcium and sulfate ions back into the hydrothermal soup.
But because the water is now below 58 degrees, those ions can't turn back into anhydrate.
Exactly. They need to find a new stable configuration. So the calcium and sulfate ions bond with the water molecules and precipitate back out as the hydrated form. Gypsum. More specifically, they form the massive, transparent selenite variety.
It's an elegant, self-cannibalizing system. The anhydrate is sacrificing itself, dissolving into the water, to act as a permanent fertilizer for the growing gypsum crystals.
It provides an inexhaustible supply of building material. But this mechanism alone doesn't explain the giants.
Right.
This was a subject of intense debate among geologists for years. If you have a cave full of mineral-rich water precipitating gypsum, why did it grow a few dozen colossal 11-meter beams? Why didn't it just coat the entire cavern in a thick crust of millions of tiny microscopic crystals?
Yes. Because if you do the classic rock candy experiment at home, where you dissolve a ton of sugar into boiling water and let it cool, you don't get one giant, perfect sugar crystal.
No, you don't.
The stick gets coated in thousands of tiny, jagged little crystals. So why did Nike choose to build a few monoliths instead of a million tiny shards?
To explain that, we have to look at how crystallization is triggered. When a mineral precipitates out of water, it needs a starting point, a nucleation site, or a seed.
Right.
If you cool your sugar water very quickly, the water suddenly can't hold all that sugar. It becomes highly supersaturated. The sugar molecules panic, essentially, and violently crash out of the water all at once, creating millions of new nucleation sites. That's why you get millions of tiny crystals.
Because there is too much energy and too much material trying to escape the water at the same time.
Precisely. But in the Cave of Crystals, the cooling process was so agonizingly slow, dictated by miles of insulating bedrock, that the water temperature settled into an impossibly perfect Goldilocks zone.
Which is what temperature?
It hovered right at 55 degrees Celsius, just a fraction below the 58-degree threshold.
So the water is only dissolving a tiny bit of anhydrate at a time.
The water was only marginally supersaturated. It carried just enough calcium and sulfate to form gypsum, but it lacked the chemical activation energy required to spontaneously spawn new nucleation seeds.
Ah, I see. The minerals in the water want to precipitate, but they don't have the energy to start a new crystal from scratch.
So they take the path of least resistance. A few initial gypsum seeds managed to form early on. Once those few seeds existed, all the dissolved calcium and sulfate in the water over the next 500,000 years had nowhere else to go.
Wow.
They were magnetically drawn to the existing crystalline lattices, locking into place, atom by atom, layer by layer.
Because the temperature stayed flawlessly locked to 55 degrees, the environment never triggered the panic crash of new crystals. It just patiently fed the giants.
For 500,000 years, the thermal stability of this chamber is almost impossible to comprehend.
It's mind-boggling.
While these crystals were growing in the dark, the surface of the Earth was unrecognizable. Entire ice ages advanced and retreated across the northern hemisphere. Human ancestors evolved, discovered fire, migrated across continents, and through all that violent surface history, this subterranean pocket maintained a steady 55 degrees Celsius without a single interruption.
The math on the growth rate is staggering because scientists didn't just guess that it took 500,000 years. They actually measured the speed, right?
They did. A brilliant team of crystallographers, led by Alexander Van Driesch, managed to replicate the exact chemistry, pressure, and temperature of the Naica aquifer in a specialized laboratory setting. They seeded the water with selenite and used advanced microscopes to watch the lattice grow.
And what was the speedometer reading on a growing 12-ton crystal?
They calculated the growth rate at 1.4 times 10 to the negative fifth nanometers per second.
Okay, I need a translation for that because negative fifth nanometers is completely abstract to my brain.
To put it in physical terms, the crystal was adding the thickness of a single human hair, or a single sheet of standard paper, every 100 to 200 years.
A hair's width per century.
Yeah. At that unimaginably slow pace, to build a beam 11.4 meters long and a meter thick, the math dictates a continuous, uninterrupted growth period of between 500,000 and 1 million years. It is the slowest, directly measured normal growth rate for any crystalline process on Earth.
That timescale induces a kind of chronological vertigo.
It really does.
And it perfectly explains the tragedy of the Cave of Swords that we mentioned earlier. The
Yeah.
Cave of Swords was only 120 meters deep. Because it was so much closer to the surface, the bedrock didn't insulate it as well.
Exactly. The Cave of Swords lost its heat to the surface much faster. It crashed through the 55-degree Goldilocks zone relatively quickly, generating higher supersaturation, which resulted in a massive number of smaller, sword-sized crystals.
But the Cave of Crystals...
The Cave of Crystals, buried at 300 meters, was wearing a thicker blanket of rock. It lingered in that perfect transition window for an eternity.
So we have established this 500,000-year geological reactor. It is perfectly insulated, perfectly balanced in its temperature, and completely lethal to human biology.
Right.
For hundreds of thousands of years, these colossal beams grew in absolute lightless isolation, stacking atoms at the speed of a hair per century. But if you are building a structure over 500,000 years in a soup of minerals and water, things are bound to get trapped inside the brickwork.
The isolation was perfect, but it wasn't empty. And this realization marks the point where our deep dive shifts from pure geology to groundbreaking astrobiology.
Which brings us to the NASA-affiliated expeditions of 2008 and 2009. Dr. Penelope Boston, a highly respected astrobiologist, led a team into this 58-degree hellscape.
And she wasn't there to measure the angles of the selenite.
No, she was hunting for microscopic anomalies.
She was looking for something called fluid inclusions. As these massive crystals slowly added layers over the millennia, the crystalline lattice wasn't always perfectly uniform.
Oh.
Occasionally, microscopic imperfections would form, sealing off tiny pockets of the surrounding aquifer water deep inside the crystal.
I picture it like a prehistoric mosquito trapped in a bead of amber.
It is the exact same concept, but instead of tree sap trapping an insect, it is a mineral trapping the hydrothermal fluid. These fluid inclusions are hermetically sealed microscopic time capsules.
Wow.
They contain a pristine sample of the water from the exact moment in deep history when that specific layer of the crystal formed.
But the physical logistics of getting that water out are mind-bending. You have a microscopic bubble of ancient water locked inside a crystal harder than limestone, located inside a cave that will boil you alive in 15 minutes.
Yeah, it's not easy.
How do you extract that sample without contaminating it while wearing an ice-filled spacesuit?
The protocol was grueling. The team had to establish absolute aseptic, sterile conditions inside a thermodynamic nightmare. They used heavy-duty drills to bore into the crystal beams, aiming for areas where lasers had identified fluid inclusions.
But drilling generates heat, right? If the drill bit gets too hot, wouldn't it just boil the microscopic water pocket before they could even reach it?
That was a massive risk. They had to control the drilling speed meticulously, often stopping to ensure the thermal friction didn't destroy the inclusion.
Good Lord.
They sterilized the surface of the crystal with highly concentrated hydrogen peroxide. They used sterile, heat-resistant gloves over their cooling suits. Once the drill breached the microscopic pocket, they used sterile micropipettes to draw out fractions of a milliliter of this ancient fluid.
All while the stopwatch on their artificial cooling systems is aggressively ticking down, it is heroic science.
Truly.
And when they finally got those tiny droplets of fluid back to a surface laboratory and looked at them under high-powered magnification, what was inside?
They found biology. They found dormant microbes and viruses suspended inside the fluid inclusions.
Ancient life.
Yes. By cross-referencing the location of the inclusion within the crystal beam with the known growth rate we discussed earlier, the geochronologists on the team could actually date the water.
Oh, wow.
They estimated that these microscopic organisms had been sealed inside the crystal for anywhere from 10,000 to 50,000 years.
50,000 years. To put that in perspective, 50,000 years ago, Neanderthals were still walking the Earth.
Yep.
The last ice age was at its peak. And these organisms were just sitting there, locked in a microscopic bubble of water inside a giant crystal, completely dormant. It highlights the staggering resilience of life.
It really does.
But we have to talk about how they survived in the aquifer before they got trapped. Because it's completely pitch black down there. There is absolutely no sunlight, so photosynthesis is out of the question.
Right. These organisms belong to a classification known as extremophiles, specifically chemolithoautotrophs. They do not rely on the sun for energy. Instead, they process the inorganic rock minerals in the hydrothermal fluid.
How does that work?
The metabolic analysis showed that these strains were extracting energy by oxidizing iron, sulfur, and manganese compounds found in the deep earth environment.
They are literally eating the rock chemistry.
It is a completely alien food web compared to the surface biosphere. But the sheer age of the microbes wasn't the most shocking discovery.
No.
The real revelation came when the team attempted to reanimate them in the lab.
Wait, they managed to wake them up?
They did. They provided them with a nutrient medium mimicking their deep earth chemistry, and the 50,000-year-old microbes resumed cellular division. They were alive.
It's insane.
And once they had a viable culture, the team sequenced their DNA to see where they fit on the evolutionary tree of life.
And the results broke the tree.
Pretty much. The sequencing results matched absolutely nothing in known genetic databases. They were fundamentally drastically different from almost all known life on Earth. When compared to their closest known microbial relatives, there was a 10% genetic divergence.
A 10% divergence in DNA might not sound like a lot to a layperson, but in evolutionary biology, that is an absolute chasm. Penelope Boston used a fantastic analogy to explain this. She said that a 10% genetic difference in these microbes makes them as distant from their closest known relatives as humans are from mushrooms.
And that analogy perfectly captures the magnitude of the divergence. A 10% difference in ribosomal RNA indicates millions of years of isolated evolutionary branching.
Right.
It suggests that these microbes have been trapped in this deep crustal environment, evolving entirely separate from the surface biosphere for an incredibly long epoch of geological time.
Okay, I hear all of this, and it is endlessly fascinating, but I have to play the skeptic here.
Go for it.
Because whenever a headline pops up saying, "Scientists revive ancient microbes," my immediate assumption is cross-contamination. I imagine a scientist sneezing in the lab or a microscopic modern bug hitching a ride on the drill bit, and suddenly everyone thinks they've found ancient life. How do they prove this isn't just a 21st century bacterium that got pushed into the hole?
That skepticism is entirely warranted, and it is exactly how the scientific method is supposed to work. Following Dr. Boston's announcement, there was fierce, rigorous pushback from the wider microbiological community.
As there should be.
Prominent scientists, like the French microbiologist Purification Lopez Garcia, immediately pointed out the massive contamination risks inherent in the extraction process.
Because no matter how much hydrogen peroxide you use, you are still operating in a dirty, dusty mine.
Exactly. Lopez Garcia argued that modern microbes living on the exterior walls of the cave, or hiding in invisible microfractures in the selenite beams, could easily have been dragged into the sample by the mechanical action of the drill.
So how did Penelope Boston and her team defend the integrity of their 50,000-year-old microbes?
Their defense relied entirely on the genetic sequencing we just discussed. Anticipating the contamination argument, Boston's team hadn't just sampled the inside of the crystals. They also took extensive swab samples of the exterior cave walls, the pools of water on the floor, and the broader mine environment.
They mapped the modern ecosystem of the cave.
Right. And when they sequenced the DNA of the modern exterior microbes and compared it to the DNA of the microbes pulled from the fluid inclusions, they found a stark contrast. The modern surface bugs were genetically distinct from the internal ancient bugs.
So if it had been a modern bug dragged in by the drill bit, the DNA would have been a 100% identical match to the bugs living on the cave wall.
Precisely. Boston argued that the 10% genetic divergence proved the fluid inclusions contained a genuinely isolated ancient population that had not interacted with the exterior cave environment for tens of thousands of years. The unique genetic signature was the fingerprint of deep time.
That is a brilliant piece of deductive science. But let's zoom out for a second and ask the big so what question. Why is NASA an agency dedicated to space exploration funding teams to drill into crystals in a Mexican mine? Why do they care about 50,000-year-old rock-eating bacteria?
Because the Cave of Crystals is the perfect terrestrial proxy for extraterrestrial environments. The search for life in our solar system has largely shifted away from the surface of planets to their deep subsurfaces.
We are looking at Mars, and we are looking at icy moons.
Exactly. Mars is a heavily irradiated, freezing desert on the surface, but deep underground, there may still be hydrothermal activity. Similarly, Jupiter's moon Europa and Saturn's moon Enceladus have miles of solid ice on the surface, but massive, dark, liquid oceans beneath, heated by tidal friction.
Environments with no sunlight, extreme pressure, and heavy mineral concentrations. Sound familiar?
Very familiar. The microbes in the Naica cave act as a proof of concept. If biology can find a way to survive and even thrive in a boiling, toxic, lightless environment on Earth by eating inorganic minerals, it vastly expands the parameters of where life might exist in the cosmos.
Wow, yeah.
The extremophiles of Naica prove that life doesn't need a warm, sunlit surface to endure. It just needs water, heat, and time.
It fundamentally rewrites our definition of a habitable zone. It is a stunning triumph of exploration. But it brings us to a very bittersweet, almost tragic phase of this story.
Yeah, it does.
We managed to extract these incredible geological and biological secrets, but our ability to do so was entirely predicated on an unnatural state of affairs.
Human presence in the cave was always a fragile, temporary anomaly. We were never meant to be there, and the environment could not sustain our presence.
And this is the great paradox of the Cave of Crystals. Pumping out the water allowed us to discover the cave, map it, and sequence its microbes. But the very act of removing the water, the act of exposing the cave to the air, was destroying the crystals.
Removing the buoyant support of the water was the first major issue. These are 12-ton beams. For 500,000 years, their massive weight was supported by the density of the hydrothermal fluid.
Right.
In the air, they were suddenly subjected to the full, unmitigated force of their own gravity. The structural stress caused massive microfracturing, but the far more insidious threat was chemical.
Because they were drying out.
Yes. Remember, selenite is calcium sulfate dihydrate. It has water woven into its crystalline lattice. When exposed to the atmosphere, even a highly humid one, the crystals began to slowly dehydrate. The water molecules evaporated out of the lattice, and the pristine, transparent selenite began converting into a dull, opaque mineral called basanite.
The crystals were essentially flaking away into powder. But there was another destructive force at play, too, right? One caused directly by our attempts to survive in there.
The ventilation. To make the cave even remotely survivable and to clear the air in the staging areas outside the door, the mining company was pumping massive amounts of forced, artificially cooled air into the deep levels.
Okay, I see where this is going based on our earlier discussion about the wet bulb temperature and the human lung, the cool air hitting the hot environment.
Exactly. The forced ventilation created an artificial thermal gradient. The ambient, hot, moisture-saturated geothermal vapors rising from the deeper sections of the fault hit the slightly cooled surfaces of the massive crystals near the entrance.
It's condensation.
Massive condensation. The crystals reached the dew point, just like the human lungs did. But this wasn't just pure water condensing. It was aggressive, slightly acidic condensation interacting directly with the gypsum. The water actively began dissolving the crystals.
It was melting them.
In some of the smaller, heavily ventilated adjacent chambers, geologists noted with horror that the giant selenite structures were actively melting away, transforming rapidly into formless calcite stalagmites.
It is a devastating irony. Our very attempt to study the Sistine Chapel of geology, our need to pump cool air so we wouldn't die looking at it, was actively erasing it.
We were destroying it just by opening the door, and this sparked a massive ethical debate in the scientific community. Do we artificially seal the cave and pump it full of water to save it, thereby ending all research? Or do we keep studying it until it degrades?
But in the end, the scientists didn't get to make that choice. Economics and geology made the decision for them. The end of our access to the Cave of Crystals wasn't a calculated conservation effort. It was a sudden industrial reality.
The timeline of our access slammed shut abruptly. The issues began cascading in 2015, and the closure became permanent by 2017.
What exactly happened to the mining operation?
Industrias Peñoles encountered an insurmountable problem. Despite their massive pumping infrastructure, the mountain fought back. There was a catastrophic, uncontrollable flooding event in the deepest, newest levels of the mine.
Oh, wow.
The aquifer surged with unprecedented
You
pressure.
were trying to empty the ocean with a bucket, and the bucket broke.
Essentially, yes. The influx of water was overwhelming. Combined with shifting global economic factors regarding the price of silver and lead and the astronomical daily cost of pumping out an Olympic pool of water every 40 minutes, the corporate math no longer worked.
Right, it's just not sustainable.
So the company made a definitive, final decision. They suspended all mining operations at the Naica Mine.
And when a mine ceases operations, the first thing they do is cut the power to the pumps.
They flipped the switch. The massive industrial pumps fell silent for the first time in decades. And without the pumps fighting the geology, the immense natural hydrostatic pressure of the regional aquifer immediately reasserted itself.
I can just picture the water rising in the darkness.
A 170-meter head of hot, mineral-rich thermal water rushed back up through the fault lines of the tunnels, violently reclaiming the empty spaces. The water level rose steadily, swallowing the 300-meter level and entirely submerging the cave of crystals once again.
The cave was swallowed back into the boiling darkness from which it came. It is now completely, irrevocably inaccessible to human beings. There is no suit, no submarine, no technology that can safely navigate a flooded, 58-degree labyrinth of jagged crystals.
It is sealed away, perhaps permanently. But while the loss of access is a tragedy for the explorers and scientists who want to continue studying it from a geological perspective, the flooding is the ultimate salvation of the cave.
That is the beautiful silver lining to this entire story. The mountain just took its treasure back. By reflooding the chamber, the threat of atmospheric dehydration is instantly neutralized. The destructive condensation from human ventilation is gone.
The crystals are safe. They have returned to their natural state of equilibrium. They are bathed once again in that pristine 55 degrees Celsius hydrothermal fluid.
And the chemistry resets.
Right, the deep anhydrate is slowly dissolving. The calcium and sulfate ions are flowing through the darkness, and the giant beans have resumed their growth.
Adding a single hair's width of thickness every century, completely unbothered by us, just as they have for the last 500,000 years.
It forces a profound shift in perspective. The Cave of Crystals is a stark reminder of the immense scales of deep time and the violent extremes of nature that operate entirely independently of human observation or desire. We were allowed a brief, 15-year glimpse into a half-million-year process.
It has been an unbelievable journey today. We have traversed a 26-million-year timeline, starting with a subterranean magma dome that set the geological stage. We explored the impossible thermodynamic balance of a 55-degree bath that nurtured 12-ton crystals over 500,000 years. We confronted the terrifying physiological reality of a 10-minute human survival window inside a 100% humidity, 58-degree atmosphere, and the space-age engineering required to cheat death for 40 minutes at a time. And finally, we witnessed the poetic return of the waters, locking the giants away in the dark.
It is a story of human curiosity colliding with planetary forces that simply dwarf us.
It really is. And as we leave you today, I want to leave you with one final haunting reality to mull over. The cave may be flooded, the massive crystal beams may be lost to human eyes forever, and the mountain may have reclaimed its silence.
Right.
But right now, somewhere in a sterile laboratory on the surface, those genetically unique 50,000-year-old extremophiles that Dr. Boston's team pulled from the crystal water are alive, they are reproducing, and we still do not fully know what they are.